Hey, welcome to day 1 of the Solutions Unit homework. I'm going to do a few on the pages 2, 3, and 4. Actually, I'm going to do a few on pages 2 and 3 because page 4 is exactly the same as page 3, just different problems. So I've got some highlighted here. This is where we start with the solutions concept. That's the page 2 of your homework. So number 2 says explain why water has a relatively high boiling point and heat of vaporization. Well, that's because of the intermolecular forces that are holding water molecules together. Remember that the intermolecular force that holds water together is hydrogen bonding. And hydrogen bonding is the strongest force of attraction. So water has a high boiling point and a high heat of vaporization because water molecules are held together by hydrogen bonding. And remember that those are the strongest force of attraction to overcome. So that's why they have high boiling point and heat of vaporization. Number 4, what's the significance of the statement like dissolves like? Well, the significance is that similar, like a polar compound will dissolve another polar compound. In order for them to dissolve, the solute has to be polar and the solvent has to be polar. And same thing works with nonpolar. So in order for a nonpolar substance to dissolve, the nonpolar solute, well, you would have to use a nonpolar solvent. So polar solutes dissolve in polar solvents. And this works the same for nonpolar also. So what does the like mean? Well, the like refers to polar or nonpolar. Polar or nonpolar. So you could substitute in polar for this. You could say polar dissolves polar. And then using nonpolar, you'd say nonpolar dissolves nonpolar. Okay, that's the significance. And it just helps us to remember that those things have to be the same. Crossed off number 9. Don't need to do number 9 because there's no table 18.1, blah, blah, blah. Number 8. Name 3 factors that influence the rate, so this is the speed, the rate at which a solute dissolves in a solvent. So you have to heat it, crush it, stir it up. That's what I always remember. Heat, particle size, and stirring. Those are the 3 things that will increase the rate that, let's say, sugar dissolves in water. So sugar will dissolve in water faster if you heat up the water. It will dissolve faster if you crush the sugar. And it will dissolve faster if you stir the solvent, stir the sugar into the water. So heat it, crush it, stir it up. So on page 3, I've got some that we're going to do here. Page 3 should look familiar to you. We did these during our covalent unit. Al2Se, 3. This is aluminum sulfide. And this is an ionic compound. So we don't really have a Lewis structure that goes with aluminum sulfide with ionic compounds. You would just have 2 aluminums with their 3 valence electrons and the 3 sulfurs with their 6. And you would show the transfer of electrons. Okay. 1 there, 1 there, 1 there. Then you would take one of this aluminum and go there, and then there, and then there. So it's just a transfer of electrons. This is an ionic compound. Is it soluble or insoluble? It's soluble in water. Aluminum sulfide will dissolve in water. Oh, just kidding. It will not. Have we gone over I don't think we've gone over solubility rules yet. I'm just going back because I just realized that that's not true. So we're going to learn about the solubility rules. So sulfides, such as aluminum sulfide, sulfides tend to be insoluble. That means that they will not dissolve in water. And they're insoluble unless they're sulfide compounds with ammonium, like ammonium sulfide, any of the alkali metal cations like sodium sulfide, or calcium strontium or barium sulfide. Well, aluminum sulfide is none of those, so aluminum sulfide will actually be insoluble. Okay, we'll talk about solubility rules later. Okay, that'll make a little more sense in the coming days. All right, the next one, that is a covalent compound. And so you don't have to write its name. Now, if you want to, you can Google its name. I believe, let's see. Let's see, what is CH3Cl is chloromethane. Okay, it's been a long time since I've had organic naming. So this is chloromethane. If you want to, you can Google that because we didn't teach you how to do those. METH, sorry, methane. Okay. To draw that Lewis structure, you'd put carbon in the middle and you'd bond each of those other atoms with a single bond, and then you'd put the remaining valence electrons on the chlorine. So recall from our covalent unit, which it's been a while, in order for something to be polar, there would have to either be different things bonded to the center atom, and there are, or you would have to have a lone pair on the center atom. Well, there's not a lone pair on carbon, but there's different things bonded to carbon. So this thing ends up being a polar covalent compound. And since it's polar, remember like dissolves like. Oh, dummy. Like dissolves like, so it is soluble in water. Okay, polar will dissolve polar. And if chloromethane's polar, that means it will dissolve in water. Let's go down here to lead chloride. Okay, this is actually lead 2 chloride. And as an ionic compound, it doesn't have a fancy Lewis structure. It's just a lead and 2 chlorines. I drew that too close together. Let's try this. And then 1 and then 1. There's a transfer of electrons. It's ionic. And let's see, lead, going back to our solubility rules we'll talk about later again. Chlorides tend to be soluble, so most chlorides will dissolve in water unless they're lead chloride. Yep, lead chloride will not dissolve in water, so it is insoluble. We'll again learn more about the solubility rules later. Boron trihydride. Okay, its Lewis structure, remember that boron only needs 3 bonds, only needs 6 valence electrons to be happy. Okay, so boron trihydride would be like that. Going back to the covalent rules, is this polar or nonpolar? Well, it would be nonpolar because you have the same things bonded to the center atom and there's no lone pair on the center atom. So this is a nonpolar covalent. As a nonpolar covalent, it's insoluble in water. Okay. If you need to replay, I completely understand. Good luck, and be sure and ask questions if you have any. I'm more than happy to answer.